Welcome to school, guys. This is going to be another calculus lesson in which we use the formal definition of the derivative for a root function. Before we enter into that new material or new skill, I wanted to go ahead and provide you with a summary of our material. It's sometimes useful to reflect and ponder on what we've done so far before continuing on with new concepts. Okay, so imagine you have a function f of x and you wanted to take the average rate of change of that function given any 2 points, right? So in this case, we're given point A, f of A, and A plus h, f of A plus h, right? The only difference between these 2 points is the step, which is a delta x, okay? So to find the slope of the secant, you take the change in y over the change in x, being h being the change in x. If you wanted to find the instantaneous rate of change, you need the slope of the tangent. And in order to do that, you need a very, very small h. So we take this idea of the limit as h approaches 0. Okay, so your h can be like, for example, 0.00001. Okay, so in mathematics, we just use the idea of the limit to basically be more, I guess, in a way be more vague, but weirdly more specific. That's sort of a contradiction, but that's essentially the idea. Now, if we could do that for eternity and find endless amount of points, but the derivative basically gives us a general expression for the rate of change or the instantaneous rate of change. So we're going to take f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. And that will be the formal definition. Now, to take the derivative of any function, you can apply this formal definition. And we have done so for polynomials, rational functions, and today we're going to be using this formal definition for root functions. Okay, hopefully I didn't lose you along the way. This is meant to be a summary. So now let's enter into some of that practice so that you don't hear me talk that much. Okay. So let's jump right in. Now, the very first step you want to do is write your definition of the derivative. So f prime of x is going to be the limit as h approaches 0 of f of x plus h minus f of x over h. Okay? And you know exactly what f of x is, but you don't know what f of x plus h is. So that is going to be the square root of 6 x plus h. For every x, replace it with an x plus h. And then we want to get rid of those parentheses. I hate having unnecessary parentheses because they just make things a lot harder to look at. So we have 6x plus 6h. Okay, so now that we have that, you just essentially go ahead and just plug it into your formal definition. So the limit as h approaches 0 of the square root of 6x plus 6h minus the original square root of 6x over h. Okay, and this will be equal to f prime of x. Okay, so now we have basically two root expressions on the numerator, and they're being subtracted. So what you want to go ahead and use is a sort of a conjugate rule in which you multiply both the top and the bottom by this. Okay, so you're gonna be very familiar with what I'm about to do. 6x plus 6h. Okay, and then instead of putting a minus, you're going to put a plus. Okay, the square root of 6x. And then, if I can write that there, close it. And since I multiply this on the numerator, I must do the same thing for the denominator. So the square root of 6x plus 6h plus the square root of 6x. Okay, so think back when you needed to basically simplify imaginary numbers, right? So this is something similar. You multiplied by a conjugate, okay? Now you're going to basically use the distributive property to basically simplify the top. So I'm not going to go ahead and work that out. I'm going to let you try that yourself, and I'm just going to give you the result. Okay, so you're going to get 6x plus 6h minus 6x. Okay, and you can do that on your own. All right, and then the bottom is simply just going to be the square root of 6x plus 6h, okay, plus the square root of, let me erase this, make it a little bit clearer, the square root of 6x, okay, and I forgot to put that h, so I'm going to write it outside. Okay, so times 1 over h, because it's the same thing as dividing the whole thing by h. All right. So now let's see what we can eliminate here, because again, it's very important to basically get rid of things that just go away, so that we make it easier. So that 6x and that negative 6x were taken out. Look at this h here at the top and this h here at the bottom. So let's eliminate this and this. Okay, and now let's apply our limit. So let's go back to red. So we're going to say this is the limit as h approaches 0 of 6 over 6x plus 6h plus 6x, the square root of 6x. So as h approaches 0, this term eliminates. Okay, and so then you're simplified to this. So f prime of x is going to be 6 over 2 times the square root of 6 times x. Okay, and if we wanted to find basically the derivative at, let's say, 1, then this is going to be f prime of 1 is going to be 6 over 2 times the square root of 6. Okay, and you can simplify that further, but I'm not going to. So let's basically go into one more example, and let's see what happens. All right.